Now let us consider a solar cell and say single solar cell, the different rating of the solar cell, maximum current equal to 4.44 amperes, maximum voltage equal to 0.5 volt, maximum power which is a product of voltage and current which is equal to 2.22 watts. For a single cell can produce a power of 2.22 watts. Now the question is, how can we generate higher wattage using a single solar cell? By single solar cell, we cannot produce that. In that case, we will have to connect the solar cells in series and parallel combination. If you connect the solar cells in series, you can increase the voltage rating. Now, if they are connected in parallel, you can increase the current rating. Therefore, by connecting the solar cell in series and parallel, you can increase the voltage rating as well as current rating, and thereby the power rating can be increased. Now consider a photovoltaic cell and photovoltaic module concept. The basic building block of a PV application is a module consisting of a number of pre-wired cells in series, all encased in tough weather-resistant package in the area of several square feet. Such an encased panel is called solar module. It's called the solar module as such. Therefore, this is a photovoltaic cell in which number of cells are, they are, included, or they are encased, kept in that, normally they can be connected in series. Solar cell can be connected series, and they can be that such a setup is called module. Therefore, the most solar PV panels have a 30 to 36 cells connected in series. For this type of cells, there are 30 to 36 cells. They are connected in series, and if each cell is having a voltage of 0.5 volt, when full sunlight is falling on that one, then the total panel voltage, will become, therefore 36 panels, they are 30 to 30. If the 30 panels, you will be getting a 15 volts. If 36 panels, you will be getting a 18 volts. Therefore, you can increase the voltage rating of the solar system by connecting different solar cells in series. Now let us see solar cell, solar module, solar panel, solar array. The concept as solar single cell, they are connected in a series manner, and if such cells are connected in this series manner, and if you can, that's we call a solar panel as such, and then such panels can be arranged as a solar array as that one. Therefore, array means multiple modules. There are multiple modules are there, and these multiple modules in turn can be wired in series. Therefore, that can be either be connected in series or parallel fashion. If you connect there in series, the voltage rating can be increased, and when they are connected in parallel, you can increase the current rating. Therefore, multiple modules in turn can be wired in series to increase the voltage, and in parallel to increase the current, and the product, which is the power rating, can be increased by connecting the panels in series and parallel, and such a setup we call it as solar array. Now consider a solar cell having the voltage 0.5 volts, and they have such a cells, 6 cells are there connected in series, so that total voltage become 6 into 0.5, 3 volts is the total voltage. And current, of course, the current rating there, since they are connected in series, the current rating of a single cell is that current rating, that is equal to 4.44 amperes. Therefore, the total power rating of this 6 cells they are connected in series, that's equal to 4.44 amperes into 3 volts, which is equal to 13.32 watts. So that is almost 13 watts it is indicated. Therefore, series connection of the solar cell increases the voltage rating of the solar panel. So that's a solar module, we call it as a solar module as such. A solar PV module is a device in which several solar cells they are connected in together to generate more power than a single solar cell. That's as I already explained. If they are connected in more number, they are in series, the total voltage rating of that can be increased. As we have seen here, if there are 10 solar cells, they are connected in series, of each producing a 0.5 volts, then total 10 into 5 volts can be generated. Therefore, by connecting the solar cell in series, the voltage rating of the module can be increased. Now let us see the connection of the PV cell in series, and then we'll see parallel. The series connection of the PV cells. Series connection. Series connection of PV cells here. Um, uh, Here we can see that one, when if this is the IV characteristics of a solar cell, current versus voltage characteristics of a solar cell here. Now, this is called the short circuit current and this is called the open circuit voltage. Now, if such a two cells, they are connected in series, here the current is same. Current through the both cells are same. That is why short circuit current does not change. And open circuit voltage gets added. That is, voltage, if we are two cells are connected, open circuit voltage will become, here it is equal to 20, again 20 plus 20, that become 40. Therefore, this is the IV characteristics of a solar cells. Of two cells, they are connected in series, and each cell has having a IV characteristic of this one. Therefore, short circuit current does not change, it is the same, but open circuit voltage gets added, so that increases. Now let us see the parallel connection of photovoltaic cell. In parallel connection, as you know that one, the voltage is same, that is open circuit voltage is same, but short circuit current gets added. Therefore, this is a short circuit current and open circuit voltage of a single cell. And if such cells they are connected in parallel, you can see that short circuit current gets doubled here, and but open circuit voltage is same. Therefore, this is the IV characteristics of a PV cells. CV cell, which are cells which are connected in parallel. Therefore, another one we can see that one, if there are four cells, two are connected in series, such two cells are connected in again parallel. Therefore, series parallel combination is here. Therefore, here you can see that since they are connected in series, we can see that one, the open circuit voltage is getting added, and such combination they are connected in parallel. Therefore, again the short circuit current is getting added. Therefore, in this type of combination where two cells they are connected, there are four cells in which two are in connected series, such a cells are they are connected in parallel. Therefore, the total IV characteristics of that such a system is equal to parallel series combination. Here it is equal to the combination of a series parallel case. In that case, the short circuit current is also getting doubled and open circuit voltage also getting doubled. Therefore, this is the IV characteristics of the series parallel connection of solar panels. Again, we coming to the solar PV array formation here. The heart of that one is a solar cell. Then such solar cells, they are connected in series, that's called modules. Such modules, they can be connected in series. This will become that's a string as such. Here you can say that such a string they are connected in series parallel combination, that will make array. So that is the purpose, is that in order to increase the power rating of the solar panel, so that if you are connecting there in series, the voltage rating is enhancing. If they are connected in parallel, the current rating increasing. Therefore, by connecting the series or by doing the series parallel combination of this one, you can enhance the current rating as well as the voltage rating, so that the power rating of the solar system can be enhanced. Therefore, array means multiple modules in turns can be wired in series to increase the voltage and in parallel to increase the current, and the product of which is called the power. Now consider a typical 36 cell photovoltaic panel in which there are 36 cells they are connected. You can see that one, they are connected in series. All they are connected in series, so that the if you are this preferred solar photovoltaic panel for most of the solar charging application, having 36 cells model with a which delivers 21 volt on open circuit and assuming a peak voltage of 0.58. For 0.58 voltage and the such a 36 means the open circuit voltage is equal to 21 volts, and reducing down to 16.5 volts with under loaded condition, because the open circuit voltage per cell equal to 0.58, and in that case if 36 cells are there, 36 into 0.5 will be getting 20. 36 into 0.5 will be getting almost 21. Here 36 into 0.5 you will be getting, this is equal to this wattage actually, 21 volts. He'll be getting here 21 volts at the output here. Now, under no load condition, but when it is loaded, when you are connecting a load, what happens is that here actually this is the practical equivalent circuit of a solar cell. There is a resistance is there, I mean series resistance is there, because of, and shunt resistance also there. See, because of the series resistance, when it is loaded, there will be drop in this series resistance and the available voltage is slightly reducing. That is why when it is loaded, the voltage is dropping from 21 volts to 16.5 volts. Therefore, that is why 36 into here the per cell voltage is reducing from 0.58 to 0.46. Therefore, that voltage is changing into 16.5 volts in full condition. Therefore, under loaded condition, this voltage is equal to, when they are connected in series, 36 cells are connected in series. Under loaded condition, it is equal to 16.5 volts. Under no load condition, it is equal to 21 volts. Now, let us see what is meant by packing factor. Packing factor, the packing factor is the ratio of the total area of the PV cell to the total area of the PV module as such. For PV cell area, if you see that this is the each PV cell here. If there are here 1, 2, 3, 4, like that one, if you take the total area of the PV cell, that is divided by what is the this area, that is total area of the PV module, that is what we call it as packing factor. For a PV module, it is the ratio of the total solar area to the total module area. Module area is this one. Solar area is the area of a single solar cell into number of cells. That will give the total solar area. That divided by what is the area of the module, that we call it as packing factor. How effectively packed that solar cells, that indicates. Therefore, in this case, if you see that one, this is the, here, this is the schematic representation, top view, this is the top view, and the cross-sectional view is shown here. And here, this is a glass here over which through which the light is falling on. This is a, PV cell as such, and there's a gap between that one. Can say that one. They're fully covered as semi-transparent PV modules, and this is actually glass one. In that one, through this one, whatever the light falling onto this one, that does not produce any electrical energy. Therefore, like this gap, how much is the area of the solar cell, that divided by the total area of the module, that is what we call it as packing factor. If it is effectively, means if this if it is near to 1, it is good as it effectively it's packed, that one, you can say that one. Anyway, this region is because of this region, the packing factor gets less than 1 because of this one, because light is falling directly through that is passing through directly, and in this case, because these are the glass. Now let us see the types of solar cell. Based on the type of crystals used, solar cells can be classified as monocrystalline silicon cells, polycrystalline silicon cells, amorphous silicon cells. There are 3 categories or 3 classification. In monocrystalline silicon cell, that is produced from the pure silicon, single crystal. Since the monocrystalline silicon is pure and defect free, the efficiency of cell will be higher for the monocrystalline. And polycrystalline solar cell, liquid silicon is used as a raw material, and polycrystalline silicon was obtained followed by the solidification process. The material contains various crystalline sizes, hence the efficiency of this type of cell is less than the monocrystalline cell. For polycrystalline efficiency, solar cell is less than the monocrystalline solar cell. Third one is the amorphous silicon solar cell, that is obtained by depositing the silicon film on the substrate like a glass plate. The layer thickness amounts to less than 1 micrometer, and the thickness of the the thickness of the human hair, for a comparison of 5 to thickness of hair is around 5 to 100 micrometer. It is less than 1 micrometer. That is, the efficiency of the amorphous cell is much lower than that of the other 2 types, polycrystalline and monocrystalline. As a result, they are used mainly to a low power equipment such as watches, pocket calculators only. This amorphous type of solar cell is used. If we compare the efficiency of the solar cell, here you can say that monocrystalline has got the maximum efficiency that to the range of 14 to 70. It's near to 20, or less than 20 only, 14 to 70. Polycrystalline around 13 to 15, and amorphous type of silicon solar cell, it is equal to 5 to 7%. That's efficiency. Efficiency means electrical output divided by what is the solar input radiation, input power as such solar. That ratio we call for efficiency. Now coming to the age of solar PV system as such, solar cell, it is clean and non-polluting. This non-polluting one. It is renewable energy. Solar cell do not produces noise and they are totally silent as such. They require very little maintenance. They are long lasting of energy which can be used for almost anywhere, and they have long time, lifetime is more, and there are no fuel cost for fuel supply problem because running cost is nothing in that. Therefore, these are the advantage of the solar system, PV system as such. Now coming to the disadvantages of solar system as such, solar power cannot be obtained in the night time, only when daytime only that is available. Solar cell or solar panels are little expensive, but nowadays the price is getting down, but presently it is little expensive. Now energy has to be stored because you cannot, that energy what producing is to be stored in the batteries, energy storing devices be stored. For air pollution and weather can affect the production of electricity. That pollutions that will be affecting the production of the electricity. Weather condition also will be pretty affecting, like partial shading or the shading of the trees or buildings on the panel, etc. And even weather condition also, cloudy days the production is less. Therefore, that is another disadvantage. And they need large area of land to produce more efficient power supply, because as you know, efficiency is quite less than 20%. Therefore, it needs more area to to tap the full energy. Area required is more. That is another disadvantage. Solar PV system. Now coming to the application, there are a lot of application in solar pumps. They are using for water supply. Then domestic power supply for appliances includes refrigeration that can be used. Ocean navigation aids, number of lighthouses are powered by solar cell. Then telecommunication system, radio transceivers on mountain tops, telephone boxes in the country can often be solar powered. The electric power generation in the space to provide, providing electrical power to the satellite in an orbit around the Earth. Medical refrigeration, village power, and telecommunication and signaling. Therefore, these are the different advanced applications of solar system. Therefore, we have seen the different applications we have seen already, telecommunication system and electric power generation in space to provide electrical power to the satellite in an orbit around the sun, and then medical refrigeration, village powering, that village power where we can, it is not accessible to the grid, power grid is not accessible, you can have a solar PV panels can be provided. Then telecommunication and signaling, a lot of applications are there. Solar PV system.